Welcome to another nomenclature video. Here, we're going to look at the nomenclature of coordination compounds. Now, there are already videos that talk about metal ions and coordination complexes, and everything that we learned there still applies here. But there are a few things that we need to remember for when we're dealing with coordination compounds. First of all, what is a coordination compound? It's like any other ionic compound that we have seen previously. It consists of a cation and an anion. The difference is that at least one of the ions will be a coordination complex. If there is only one coordination complex within the compound, then the other ion is what we call a counter ion. So the counter ion may be either the cation or the anion, depending on the specific compound. How do you know what the counter ion is or how to find it? It's always shown outside of the brackets in the chemical formula. So what you'll do is you'll use the charge of the counter ion to determine the charge on the complex. And once we have the charge on the complex, we can apply all of the other rules and strategies that we learned to figure out what we need about the complex itself. Finally, when we go to write the compound name will be two words: cation name first, a space, and the anion name. When I'm faced with a coordination compound, I like to figure out at the very beginning which part is the cation, which part is the anion, and determine the charge on the complex, so then I have all the information I need to do the rest of the work. So following the guidance earlier, we look for the counter ion outside of the brackets. So here's our counter ion, SO4. We will always know the charge of the counter ion because it will be something that is familiar to us. So our counter ion is SO4, and sulfate always has a -2 charge. That enables us to know that the charge on the complex has to be a +2 because the cation and the anion in this example combined 1 to 1. There's one cation because there's no subscript on the outside of the brackets, and there's one anion for similar reasons. So now we can take a look at the coordination complex and see what the different parts are. Our metal ion is right there. We know that it's cobalt and that we're going to have to figure out its charge, and we'll do that in just a little bit. What else do we have within the complex? We have our first ligand right here, which is chloride. There's only one of them, so its name will be chlorido. We also have an ethylene diamine, and there are two of them, so that will be bis. Remember, we have to use the special prefix if there's already a prefix as part of the name of the ligand. So this will be bis ethylene diamine. And we also have water, only one of them, so that ligand is aqua. The chloride has a -1 charge. The ethylene diamine and the water are 0. So knowing those charges and the charge on the complex, we can figure out the charge on the cobalt. So I'll go ahead and do that now, and then we'll figure out how we're going to arrange everything within the final name. So we'll have X for cobalt plus 1 times a -1 for the chloride plus 0 plus 0 equals the charge on the complex, which is a +2. Simplifying this, there are a lot of zeros, so it's not too difficult. We have X minus 1 equals +2, or X equals +3. That makes our metal ion cobalt 3. Now we're just about ready to assemble everything. Remember that the ligands will go in alphabetical order according to their name. not including prefixes. So we have a C, an E, and an A. So the A will go first, the C second, and E third. Assembling this all together in the name of the complex, remember we still have that anion that we have to deal with, but to just write the complex name for right now, we have aqua, chlorido, bis, ethylene diamine, cobalt 3. And that is just the cation. What is the rest of it? It's our counter ion. Our counter ion was SO42- sulfate, and so then we write a space, or I should say we leave a space. We don't write a space. We leave a space, and then we write the name of the anion, which is sulfate. In this example, we'll take a similar approach. The first thing I'm going to do is look for the counter ion. It's right here. So in this example, it is the cation. So my cation is K+. My anion is the complex. The charge on my complex will be a -1 because I have a +1 that has to combine with the charge on the complex. Figuring out the different parts of the complex ion, I have my metal ion. I know that it's silver. Remember that we have to name the metal ion according to the type of complex that it is in. Because the complex is the anion, that means that I don't just name this as silver, I name this as the modified name that has ATE. And it turns out that silver is one of those that has a special name, argentate. I'll figure out the charge on that in a little bit. I still have to include the Roman numeral, even though the format of the name is a little bit different. What else do I have in the complex? I have 2 bromide ligands. So I will name that part as dibromido. So to figure out the charge on the silver, I have X for silver plus 2 times a -1 for the bromides has to equal the charge on the complex, which is a -1. And when I do the math, I end up with X equals +1. So even though the complex is an anion, the silver ion, or the metal ion, is always positive. So this will be argentate 1. Let's go ahead and put together the name of the complex. I only have one ligand. Ligand goes first, then metal ion. So it's dibromido argentate 1. That's my anion. When I name a compound, I need to include the name of the cation and a space and the anion. In this example, my counter ion was the cation, so it has to go first. So my counter ion is potassium, and then I have a space, and then I have the name of my complex anion. So the name of the compound is potassium dibromido argentate 1. In this example, we're going in the opposite direction. And I know that the names can sometimes look like a big mess. It's important to just take it piece by piece, figure out what all the parts are, and then what you need to do with them. A coordination compound will always have a cation, a space, and an anion. So we'll start by just identifying those 2 parts. The second part is always the anion. That's right here. So sulfate is my anion, and I know that it looks like SO42-. At this moment, I don't know how many of them I need to incorporate into the formula, but I will figure that out along the way. That means that all the rest of this is my cation. And that is my complex. That is my coordination complex. So at this point, I can just use the same strategies that I've used previously to figure out everything that's there. My metal ion is named last within the coordination complex. It's right here. The Roman numeral tells me the charge, so I know that that's Fe3+. The ligands are all before it. So I'm just going to go in order and figure out what I have. My first ligand is bromido. I only have one, so that's Br-. Now, even though we don't include the charges when we write the formulas, the final chemical formula, I do like to include the charges when I'm first writing down the information, because I'm going to need to use those charges to figure out the overall charge on the complex. My next ligand, cyanido, so that's cyanide. And then I have bis, which is 2, ethylene diamine, which I write as En in parentheses. So in the formula, it's going to look like that. To figure out the charge on the complex, you do need to do this because otherwise we don't know how the two ions combine. So this is just like the old rules for regular ionic compounds. You need to know the charge on the cation, the charge on the anion. Those two charges tell you how the ions combine to form a net neutral compound. So figuring out the charge on the complex, I have my metal ion, I have one bromide, I have one cyanide, I have 2 ethylene diamines. So X equals 3 minus 1 minus 1, which is a +1. So once I figure out what my chemical formula looks like for my complex, I know that my cation is going to have a +1 and my anion has a -2. So when you write the ions side by side like that, you can see very clearly how they combine, and that you'll have to use that crisscross method like we used when we learned about ionic compounds. So the next part of this is to figure out, how do I write everything in the chemical formula? The metal ion goes first, and then the ligands will go in alphabetical order according to their symbols. So I have a B, I have a C, and I have an E. It doesn't always work out this way that they will go in the same order in the name as they do in the formula, but it does work out that way here. So the bromide goes first, then the cyanide, and then the ethylene diamine. So writing the complex, metal ion, then I have Br, Cn, En2. I already determined the charge on the complex, and we wrote this over here. We know that because the charges are not equal and opposite, they're going to have to combine like this. So the 2 comes over here, and then I have only one sulfate as my anion for the final chemical formula of the compound. In this example, my counter ion is my cation right here. So I know that I have Na+, and the rest of it will be my complex ion, and I will figure out the charge on that shortly. So looking at my complex anion, my metal ion is over here. Because the complex is an anion, my metal ion takes on a modified name. Chromate tells me that the metal ion is chromium. The 3 for the Roman numeral tells me that it has a charge of a +3. Figuring out what the ligands are, I have amine, only one of them, looks like that, and then I have a pentachlorido. So I have 5 chlorides. And when I write those within the complex, it will look like Cl5. The next thing I'm going to do is figure out what is the charge on my complex. So I have a +3 coming from the metal ion. I have 1 amine, and I have 5 chlorides that are -1s, and that is going to equal x. And when I do the math, I end up with x equals 3 minus 5, or -2. So I'll write that over here next to my set of brackets, and that shows me how those two ions are going to combine when I get ready to write the entire formula. The charges are not equal and opposite. I have a +1 for sodium. I have a -2 for my complex. So I'll have to crisscross to move those subscripts around. So to write the formula for the complex, I will start with the chromium, and then the ligands will go in alphabetical order according to their symbols. I have an N and I have a C. So the chlorides will go first, followed by the NH3. So when I write the complex, brackets, Cr, Cl5, NH3. The complex is the anion, and we know that because we have a sodium +1, the anion has a -2, that my counter ion is written as Na2.